In today's lesson, we're going to divide polynomials using long division. So we're going to start with reviewing how to divide polynomial by a monomial. So we take each term in the numerator and divide by the term in the denominator by dividing coefficients and subtracting exponents. So in the first example, we will get 2x squared minus 5x plus 1. In number 2, even though we have more variables, we have a variable a and b, we're going to follow the same rule. Divide coefficients, subtract exponents, which will give me 3 a to the power of 4 b squared minus 2a squared b to the power of 1, but we don't write exponent 1, plus 9. When dividing polynomial by binomial, first we want to always try to use factoring when possible. So in example number 3, trinomial and numerator can be factored by looking for the factors of 10 that add up to -7, and the factors are -5, -2. So I can rewrite the numerator as w minus 5 times w minus 2 over w minus 5. And I notice that there is a common factor in numerator and denominator of w minus 5, which I can reduce, and gives me the answer of w minus 2. So I just divided this polynomial by w minus 5. In example number 4, you may want to rewrite first as a fraction. So we're going to have 4h squared minus 7h minus 2 divided by a binomial of h minus 2. And then we want to factor the polynomial in numerator. And so first we have to multiply 4 times -2, which is -8, times -7. Then you find the factors of -8 that are up to -7, and the factors are -8 and 1. So I'm going to rewrite the numerator as 4h squared minus 8h plus 1h minus 2. Let me keep my denominator along, and I'm going to factor by grouping in numerator. So the common factor, that's just h minus 2 plus 1 times h minus 2 over h minus 2. And the common factor clears out, and I have 4h plus 1 times h minus 2 over h minus 2. So now I can reduce the common factor of h minus 2, and my answer is just 4h plus 1. We're going to introduce two very important theorems for this lesson, and this is really the fundamental really theorems in algebra, and the remainder theorem. So the question is, why do we even divide polynomials? And we divide polynomials to reveal zeros, to reveal solutions to a polynomial equation that will help us graph and will help us identify the x-intercepts. And the remainder theorem provides one of the most important applications of polynomial divisions. And it states, if you divide f of x by a factor of x minus a, and get a remainder of 0, then x minus, it should be an a, there's a typo, please fix it. That should be a. X minus a is a factor of f of x. And later on that leads to find the 0 of the polynomial. The remainder theorem provides another application to a polynomial division, evaluating a function. It states if you divide f of x by x minus a, the remainder r is the value of f of x when x is equal to a. In other words, at f of a, if you evaluate function at a, you get the remainder. So sometimes the factoring is not possible. Then long division is one of the methods to divide polynomials. And we're going to use the same approach as you would divide with numbers in middle school. We're going to use the same approach for dividing polynomials. So here n minus 7 is the divisor, 2n squared minus 16n plus 19 is the dividend. So we're dividing 2n squared minus 16n plus 19 by n minus 7. So we're going to write the divisor outside. And I'm going to write the dividend under. Now, the way we're going to divide, we're going to look at the first terms. So 2n squared divided by n is 2n. So we're going to write the answer on top. Now we're going to multiply my answer by both of the terms in the divisor. So 2n squared times n is 2n squared. 2n times negative 7 is negative 14n. Now we're going to subtract the terms. So 2n squared minus 2n squared cancels out. And now I have negative 16n subtract negative 14, which means I am adding. That will give me negative 2n plus 19. And I'm going to repeat the process. I'm going to look at the first term and divide by the first term in the divisor. Negative 2n divided by n will give me negative 2. Then I'm going to multiply negative 2 times both n and negative 7. So negative 2 times n is negative 2n. Negative 2 times negative 7 is positive 14. I'm going to subtract again. Negative 2n minus negative 2n cancels out. 19 minus 14 is 5. I'm going to label it R, which means 5 is the remainder. The way we write the answer to this problem, you take your answer, which is 2n minus 2, and you're going to add the remainder over the divisor. This is the answer by dividing two polynomials together. And example number 2. My divisor is 3y plus 2. My dividend is 3y to the power of 3 plus 2y squared minus 12y minus 8. And again, we're going to start by looking at the first term of the polynomial, divide by the first term of the divisor. So 3y to the power of 3 divided by 3y gives me y to the power of 2. And then I'm going to multiply my answer by both terms in the divisor. So y squared times 3y is going to be 3y to the power of 3. Y squared times 2 is 2y squared. Then I'm going to subtract. So the first two terms always cancel out. Now 2y squared plus negative 2y squared cancels out as well. It happens, not all the time, but sometimes it does happen. Then I'm going to bring down the next two terms. You always want to have two terms if you're dividing by a binomial. So now repeat the process. Negative 12y divided by 3y is negative 4. Negative 4 times 3y is negative 12y. Negative 4 times 2 is negative 8. Now we're going to subtract. Both of the terms cancel, which means I have a remainder 0. Remainder 0 by the remainder theorem says that 3y plus 2 is a factor of the polynomial 3y to the power of 3 plus 2y squared minus 12i minus 8. Now I can write my answer as the product of two binomials. I have no remainder, which means 3y plus 2, my divisor, multiplied by the answer, is a factored form of the polynomial that we divided. Sometimes you're going to have missing powers in the dividend or the divisor, which means if you need to take a note, you need to replace all the missing powers with either in the dividend or the divisor, and just like in the following manner. So x plus 2 is my divisor. It goes on the outside. Inside I have x to the power of 3. X squared is missing, so I'm going to write 0x squared instead. X is missing, so I'm going to write 0x plus 8. And I'm going to repeat the process. If you need to take a moment, pause the video, work out this example on your own. When you're ready, unpause to check your work. I'm going to continue, so I'm going to divide x to the power of 3 by x. My answer is x squared. Multiply back, which gives me x to the power of 3 plus 2x squared. Now I'm going to subtract. So I get negative 2x squared plus 0x. And if I divide negative 2x squared by x, I get negative 2x. My colors don't match. Then I'm going to multiply negative 2x squared minus 4x. Don't forget, you're subtracting, which means you have to change the signs. That gives me 4x. Bring the last term down and repeat the process. 4x divided by x is 4. Multiply down. 4x plus 8. Subtract. Both terms cancel out, which gives me remainder 0. So now I just factor this polynomial, and my factors are x plus 2 times my answer, which is x squared minus 2x plus 4. Now in example 4, the missing power happened to be in the divisor. So we need to substitute 0 for any missing power. My divisor is x squared. It has a missing x, so we have to put it in, put 0x for it, minus 4. And we divide 3x to the power of 3 plus x squared plus x minus 1. And we're going to repeat the process. At this time you should be able to do a few steps on your own, maybe all of them. So try it, pause the video again, and try to work it out. So first term, divide by first term, we will get 3x. Remember to multiply down now by 3 of them. Which gives me 3x to the power of 3 plus 0x squared minus 12x. Now we're going to subtract. I use different approaches with subtracting, so you have to pick the one that works best for you. Remember, this negative that's outside applies to every single term inside the parentheses. So now I have x squared minus 0x squared, which is still x squared. X minus negative 12 is going to give me 13x. Since I'm dividing by 3 terms, I have to bring the next term down. And I repeat the process. X squared divided by x squared is 1. Multiply 1 times x squared plus 0x minus 4. Then I'm going to subtract. X squares cancel out. 13 minus 0 is 13x. Negative 1 minus negative 4 is going to be, so we have technically we have negative 1 plus 4, which is 3. So now if you look at the first term, which is 13x, the power is less than the divisor, so we cannot divide x by x squared, which means 13x plus 3 is my remainder. So my answer, since I have a remainder of 13x plus 3, is going to be 3x plus 1, and you have to add the remainder over the divisor. And the last part of this video is we want to state if the given binomial is a factor of the given polynomial or not. And division is one way to decide. If you get the remainder 0, you definitely know that your divisor is a factor of the given polynomial. But this is a lot of work. So there's a shortcut, there's a shorter way to show if a binomial is or is not a factor. And we're going to be using the remainder theorem. And if you go back to the beginning of this lesson, you can probably read it again and trying to figure out if you substitute the potential 0 into the polynomial, we call it a synthetic substitution. And if the answer comes out to be 0, then you have a factor. If it's not, then you don't have a factor. So in example number 5, I'm dividing by b plus 7. So first I want to solve this for a potential 0. So I'm going to set this factor equal to 0, which means by b is negative 7. And the way I'm going to check, I'm going to substitute negative 7 for each b into my dividend. So I'm going to plug in negative 7 and I'm going to cube it, plus 10 times negative 7 squared, plus 22 times negative 7 plus 7. And I'm going to use a graphing calculator or any calculator you have on hand to actually simplify it. And if you do, my answer is 0, which means b plus 7 is a factor because the remainder is 0. Now let's check in number 6 if n plus 6 is a factor or not. So n plus 6 is 0. I want to find out what I'm actually substituting in, my potential 0 or not. And I'm going to substitute negative 6 for each n into my dividend. If I simplify, I get 6, not a 0. The meaning of it is n plus 6 is not a factor because the remainder this is s, is not 0. This is a short way to check if we have a factor or we don't have a factor of a polynomial. This video is a little longer than other videos, so look over your notes and in your own words write the procedure for dividing polynomials. That it will help you in the future, which means make your own hints